In Science We Trust, a critical look at medical research. The comment, "In God we trust, for everybody else we need data," lingered in the minds of many medical practitioners for years. As they went deeper into medical journals, academic works, news media, and their patients' experiences, a question arose. How trustworthy is medical science if the data is flawed or false? Blind acceptance of clinical trial results gave way to a more skeptical approach, categorizing studies into 4 types: flawed, frivolous, falsified, if not fraudulent, 4F studies. Even evidence-based medicine seems to chase a moving target. As Matt Ridley aptly stated, there is no such thing as the science. There are different scientific views. The COVID-19 pandemic has exposed a public distrust in science unlike ever before. Follow the science has become a confusing mantra at a time when public trust in science, politicians, and government is at an alarming low. A closer look at clinical trials and meta-analyses, published in reputable journals worldwide, reveals that waste, fraud, and abuse can infiltrate both medical research and healthcare practices. The research industry churns out thousands of trials annually, a multi-billion-dollar enterprise. While the U.S. and other developed nations reap the rewards of heavy investment in biomedical research, a crucial obligation arises: efficiently evaluating the risks and benefits of new technologies and treatments against existing options. Not all trials deserve biblical reverence in guiding patient care for entire populations. Implicit bias, pervasive in human behavior, can infiltrate these studies. Researchers might overlook known or unknown confounding factors like comorbidities and genetic differences in participants. Confirmation bias is another culprit. Scientists with their own theories can gather data to bolster their beliefs while ignoring contradictory evidence. Bias and confounding are deeply entrenched problems. A critical eye is needed on every aspect of clinical trials: the patients, the investigators, and the methodology, both scientific and financial. Healthy skepticism is essential towards data analysis, reporting, publication, and dissemination across various media. Endorsements and recommendations by medical associations and guideline committees require scrutiny. Clinical trials, though based on statistically tested observations, offer probabilities, not certainties. A more philosophical approach is needed, acknowledging that scientific truths are rarely absolute or binary. Study design, conduct, choice, and interpretation of results, and statistical manipulations all influence conclusions in clinical research. Medical research is a complex cocktail of science, business, profession, and profit, all navigating the digital world with analog minds. Genetic variability and individual biases further muddy the waters. This inherent conflict challenges the validity of the science, forcing clinicians and patients to critically examine research outcomes and conclusions. Stuart Ritchie's book, Science Fictions, argues that science struggles with self-correction, potentially leaving published truths riddled with errors. Many established scientific theories and claims need challenging due to potentially unreliable, exaggerated, or even fraudulent research. Consumers of research must be aware that peer review doesn't guarantee flawless scientific articles. We all strive to rationalize our beliefs, often denying the influence of biases. However, public confidence must trump conflicts of interest, a root cause of confusion and mistrust in clinical research. Claude Bernard reminds us that initial feelings of possessing absolute truth soon dissipate with study. An optimistic view of science holding all medical answers can be dangerous. As Sir William Osler said, medicine is a science of uncertainty and an art of probability. Marcia Angel, former editor of the New England Journal of Medicine, reluctantly concluded that much published clinical research is unreliable.